All right there, ladies and gentlemen. How you guys doing? Yep, here we have homework 2.4. Let's go ahead and get into it. Maybe a little thing you should know before we begin is that we will be having our first online quiz tomorrow. We didn't announce it in class. We didn't really get a chance to, but that's how it goes. But we'll have an online quiz tomorrow. But we'll prepare for a little bit of that now. Certainly been keeping up with the homework. You can be well prepared. If not, well, you got to think maybe about your habits. If you're not preparing yourself to take these quizzes, because we are going to have them very regularly, you're going to not be preparing yourself to pass this class. But based on what we talked about at the end of class today, we should be able to multiply these out pretty fast. Here we have a negative 1 times a, here we have a negative 1 times a positive 9, so I automatically know my number will be negative. Oh, overshot a little bit here. Let's dial it back. Okay. So yeah, we automatically know we're going to have a negative answer. Then all we really have to think about is like what's 1 times 9. And of course, in this case, 1 times 9 is going to be 9. Negative, of course, because one's a negative, one's a positive. Boom, negative 9 is your answer. 12 divided by negative 6. Again, let's do this in two parts. I have a positive number 12 divided by a negative number 6. I know my answer will be negative. 12 divided by 6. Let's forget about the signs now we've taken care of it. 12 divided by 6 is just 2. All right, keep going here. Negative 6 divided by negative 6. Well, first of all, a negative times a negative divided by a negative is going to be a negative. Excuse me, a positive. Good Lord. Okay, a negative divided by a negative is going to be a positive number. 6 divided by 6 is just 1. So we end up with a positive 1. Notice I'm doing this in two steps. First, I'm evaluating the sign, and then I'm taking care of the actual problem itself. Here we have a positive number divided by a negative number. I know my answer will be negative. 80 divided by 8 is just going to be 10. That's a viable strategy. It's one I still use actually in my everyday life. We have 8 times 12. First of all, I have a negative times a negative. I automatically know my answer should be positive. Now I just have to figure out what 8 times 12 is. Well, I'm not going to be a hero. I'm just going to work it out. 8 times 2 is 6. That's 16. 8, 9, 96. Positive, of course, because we had that negative times a negative. Over here. Okay, let's keep going. We have a negative divided by a negative. My answer should be positive. 55 divided by 11 is just 5. Positive, of course, because we have two negatives. 7 divided by 1. 1 negative means it is negative. 7 divided by 1, well, anything divided by 1 is just itself, just a 7. Here we have a negative 6 times a negative 4. That's going to be positive. 6 times 4 is going to be 24. Well, positive, negative, negative. 6 divided by 6 is 1. Negative times a negative is a positive. 5 times 10 is 50. So again, notice I'm doing this kind of in two steps. One, I'm taking care of my sign, and then the second thing I'm going to do is actually handle the numbers without even thinking about the sign. So it's just a strategy you can use. All right, so the students mix up rules with sign numbers. Go figure. That actually happens all the time. A negative plus a negative is a positive. Negative and a negative is a positive. Now, notice we're adding here. So what we really have to consider is that if I have a negative number, then I put more negative numbers to it, will it become a positive? That's actually false. And here's a counterexample. Let's say it's 3 degrees outside. Actually, let's say it's negative 3 degrees outside. And then let's say it is going to drop 5 more degrees. Well, the answer is going to be a negative number. So if I'm really starting negative and I continue in the negative direction, my answer always should be actually negative. Let's go to Beth. A negative times a positive is a negative. That's going to be a true statement. That's one we established in class today. Okay. A negative minus a negative is a positive. This one's actually going to be false. Now, this is one that most people actually mistake, but let's take this for example. If let's say I have negative 4, and then I want to subtract off a negative 2. Well, you know from your work today, at the end of class today, that a negative and a negative together make a positive. So then in this case is going to be negative 4 plus 2. Well, negative 4 plus 2 is still going to actually be a negative 2. So there's an example that disproves that one. Courtney's right some of the time, but equal amount of time she's going to be wrong. Fine, let's go to David. The answer to a positive plus a negative could be positive, negative, or 0. It depends on the numbers you're adding. That's absolutely right. So if I have like a 4 and then plus a negative 2, that's going to be a positive 2. But if I look at a 4 plus a negative 6, that's actually going to be a negative 2. That's going to be a negative. It all depends on what you're looking at. And of course, if you want the 0 case, 4 plus a negative 4, that's going to be a 0. So there are examples where negative and positives can't, let me back up. So the thing to take away from this is that the rules themselves are kind of, I would hesitate to memorize. I would certainly look at the numbers first and kind of have some basic idea of how to interact with the numbers. I wouldn't go with like a global rule like this and this will always be this. Like the only Sith deal in ultimates, like you don't want to have to deal with that. All right, so let's evaluate. Now, evaluate is just a really fancy way to say put it in and solve. So what I mean is this: make a basic observation that A and 2 are the same thing, that B and -3 are the same thing, and that C and 4 are the same thing. So when I look at this problem over here, I have A squared times B. That's really just saying I have 2 squared times -3. And then I can use my rules. I know how to kind of deal with these to take these down to a smaller version of the question. So 2 squared is the same thing as 2 times itself twice. So 2 squared actually ends up just being a 4. And then I'm going to have a times a -3. So a positive times a negative will end up being negative. 4 times 3 is 12, so we're looking at a -12. Okay. I'm not going to color code things so nicely for the rest of these, so just kind of be aware. B squared plus AC. Well, B squared is going to be -3 squared plus A, which is 2, plus C, which is 4. Now we just worked this out. 3 squared, -3 squared, excuse me, is the same thing as -3 times -3, which is just going to be a positive 9. 2 times 4 is going to be 8. 9 plus 8 is 17. Let's look at this guy over here. Let's go pink. Okay, so I have a -2 times B, and referencing up here, B is -3, plus 2 times C, and C in this case is 4, all divided by B, which was -3. Now here we have to be careful. We have to use the order of operations, but let's not freak out. Let's just do one thing at a time. So here I have in my parentheses, change colors, 2 times 4, which is 8, -3 plus 8, which is 5, -2 times 5, which is the -10, divided by -3. So this ends up being just positive, of course, because negative divided by negative is a positive. 10 over 3, which is an okay way to leave your answer. If you want to use a calculator, you end up with 3.3 repeating. Okay, so we have 6 times A minus C. A was 2, minus C was 4. Over B, which is just -3. And again, we're not going to freak out. One piece at a time. That's how we're going to do this. 2 minus 4 is a -2. 6 times a -2 would be a -12. And then -3. Negative and a negative make a positive. 12 divided by 3 is 4. Okay, check this out. So we have -b squared. Now, notice I'm going to use some parentheses here because b itself is -3, and we're going to square it, plus a, which is just 2, plus c, which is 4. Okay, so check this out. -3 squared is the same thing as -3 times itself. So -3 times -3 is going to be a positive 9, but we have this negative guy right here, so the whole thing ends up being a -9. We have plus 2 plus 4. -9 plus 2 would be a -7. -7 plus 4 would be a -3. Right? So let's talk about your staying sharp. Wait, hold on. Okay. Complete the next 3 patterns or terms in this pattern below. So we have to know what the pattern is or how it's kind of gaining. So here's how I'm seeing it. I have this dot, and that carries over. And then I add kind of a row of dots on the outside. In this case, I'm adding 3. So now I have these guys, and it looks like I'm doing the same thing. I'm adding like another row. Okay, so now I have this many. And so now I'm adding another row. So if I want the next one in this pattern, I got to start out with this 4x4 block. And then I'm going to add a row on the outside, making it a 5x5 block. Okay. And we should go ahead and mark that down. That should be 25. And then 5 times 5, that is 25. Hey, go figure. So this one should be, how many do I have to do? 3? Okay. So 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 6. Okay, so then we have one more row that goes on top of that. So it was a 5x5. Oh, I kind of messed up. Hold on. Okay, so it was a 5x5. I should have used purple. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm just going to do this one. It's all messy. Okay, so we take what we had before, which is a 5 by 5. Okay, then we're going to add a row on the outside, making it a 6 by 6. Okay, so 6 by 6 should be 36. So then we'll start out with a 6 by 6. 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we'll add a row on the outside, making it 7 by 7. And that should be 49. Now, if you're looking at these numbers, you can probably pick out a pattern pretty easily. But just that's for you. Okay, where do the square numbers 1, 2, 3, 4, 1, 4, 9, 16 get their name? Hint, look at your question 1. Well, look at these. 1, 4, 9, 16, 25, 36, 49, which was, of course, the result of like 2 times 2, this is 1 times 1, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. So they get their name because if you pattern it out, you literally end up with squares. An alternative explanation is if you think about how to write 1 times 1, you can actually write it as 1 squared. This is 2 squared. A number times itself is going to be that number squared. That's going to be 4 squared, 5 squared, 6 squared, 7 squared. So that's another way that they actually get their name. Let's look at this one. Jim picks a number. He doubles it, then let's slow down. Jim picks a number. He doubles it, and then adds 5 and gets 41 as a result. What was the original number that Jim picked? Here's your answer with supporting work. So he picks this number. I'm just going to make it like an empty square. He doubles it, and that means he multiplies it by 2, and then he gets this number right here. He then adds 5 to it, and he gets 41 as a result. So if we kind of think about working backwards, we took this number, added 5 to get 41. So if I'm going in reverse, I want to subtract 5 to get to this guy. Multiply by 2, working reverse, I'm going to divide by 2. So that's how we're actually going to work this guy out. So 41 subtract 5, okay, should be 36. And then if I take 36 divided by 2, that should get me 18. So 18 is that original number. So again, it's kind of a review. If we know how to go forward from that number, we should know how to go backwards too, right? So 18 was a number that he actually picked. Okay, matchsticks are used to make the pattern shown. 4 squares require 13 matchsticks. How many squares can be made with 40 matchsticks? Well, first we have to get a sense of how this is actually working. And sometimes the way we can do this is to simply start establishing a pattern. So if I have 1 square, that's going to take 4 matchsticks. So we can actually work that out down here. So here's squares, here's matchsticks. So 1 square, 4 matchsticks. Okay. If I want 2 squares, I'm going to need the 4 from before, but then I need 3 more. So 2 would actually get me 7 because I have the 4 that I started with in orange, and then 1, 2, 3 more to make 7. If I want this third one, I'm going to again need 3 more. So that's going to be 10. And then 4, 3 more is 13, which we are told, which confirms like the way we're thinking is really good. So if I want to know how many can be made with 40, I can actually just continue this pattern, which I think that might be the way I'll take. So 5 is going to make me 17, 6 should be 20, 7 should be 23, 8 should be 26, 9 should be 29, just adding 3 every time, so that'd be 32, 35, we're getting close, 38, and that'll be 41. So with 40 matchsticks, which we don't really have enough to make the full 13, we should be able to make 12. Okay, so Mark got 6 out of 40 incorrect. How many did he get correct? What percent of the questions did he get correct? Well, we can do this a couple different ways. And the way I think I'm going to take is to try to figure out what percentage you got incorrect, and then the rest from 100 should be the goal. So when you think about percentage is just a part of a whole. So what we're actually asking is when we ask what percentage did you get incorrect, is what part of the whole did you get incorrect? Okay. Now this sign right here is interesting because that just turns out to be a division problem. So if we just take 6 divided by 40, we got 15% incorrect. So if we want the percentage correct, it's just going to be the rest of it. So we could do this a couple different ways. We can acknowledge that if he got 6 incorrect, that he had 34 correct out of 40 total. And then calculate that as just 34 out of 40. The other thing we can do is say, well, look, if he got 15 incorrect, the rest up to 100% should be his correct value, and that should be 85. So we can check it a couple different ways. The 34 divided by 40 is 85%, but also 85 plus 15 is a total 100%. So a couple different ways you could attack that problem. Okay, what is the value of 3 times 5 times 6 times 2 plus 1? We have to observe some order of operations here. So 3 times 5 will give me 15. 6 times 2 will give me 12 plus 1. Now we do the multiplication first because, of course, the order of operation is please excuse my dear Aunt Sally. Parentheses, which we had none. Exponents, which we had none. Multiplication comes first, left to right. We don't have division. That means we're on the addition step. So addition, 15 plus 12 should be 27 plus 1, which give me 28. Okay, now that's another question here. Okay. Insert parentheses, so the value of the expression has a value of 67. Well, let's look at so right now, if we just add left to right, we get 28, which means we need to increase what we have. I think the one way you can increase what we have is maybe using parentheses right here. Let me erase that, get a little closer. So what I mean is, if I use parentheses here, that forces me to do this part first, which will be 11. 3 times 11 now gives me 33. Times 2 would give me, and I'm getting the times 2, by the way, right here. 33 times 2 would give me 66. And then the plus 1 would give me 67. So you can notice just by adding parentheses around the 5 plus 6 forced me to do that first. Because again, please excuse my dear Aunt Sally. Ooh, you go away now. I don't even know what you are. Okay, so please excuse my dear Aunt Sally. Parentheses comes first. So if I put parentheses here, and I'll use a different color to emphasize what I mean. If I put parentheses here, it forces me to do the 5 plus 6 first, making that value 11. So then when I start with a multiplication of 3 times 11, I'm ready to 33. So just a cleverly chosen parentheses can actually change the value of the entire expression quite a bit. And this has me verified, but we did it right here, so I don't have to do it again. All right, guys, that's it. So I know I went fast with parts of this, but it's a video, so certainly you can rewind and watch it again. If you have questions, make sure you come to classroom tomorrow. And that's all I got for you guys, so thank you.